Good morning. In this session we will take some problems based on force between parallel currents. A long straight wire AB carries a current I amperes. A proton P travels with a speed v. Parallel to the wire at a distance d from it in a direction opposite to the current. As shown in the figure. What is the force experienced by the proton? And what its direction? First take down the figure also. I, and this is the conductor AB, and proton is here. This is P proton, and it is moving in the opposite direction with velocity v at a distance d from the wire. A long straight wire AB carries a current I ampere. A proton B travels with a speed v parallel to the wire at a distance d from it in a direction opposite to the current as shown in the figure. The current in the wire is upward and the proton is moving in the downward direction. What is the force experienced by the proton and what its direction? Now we know when a charged particle, a proton or electron, moves in a region of magnetic field, the magnetic field experiences a force on it. The proton experiences a force due to magnetic field, or the field exerts a force on the moving charge. Now here, because we have a straight conductor AB which carries current I ampere, this current produces a magnetic field around the conductor. Now the proton is moving in the field which is produced by the current in the conductor. So first we need to calculate what is the field produced by the current in the conductor AB. Then we can find out the force. First let us try to find out what is the field produced by the current I ampere. So magnetic field at a distance d due to current I in conductor, due to current I is, we can write due to current I is B is equal to, because this is a straight conductor, the magnetic field at any distance, at any point at a distance t is given by mu naught by 4 pi mu naught by 4 pi into 2I by d. Magnetic field at a distance d due to current I is, so magnetic field at a distance d due to current I is B equal to mu naught by 4 pi into 2I by d. Now how can we mark this? To know the direction of this field, we need to use the right hand grip rule. If this is the current I, A and B, and we have P here moving in the opposite direction. Now field due to the current I is B, and to know this direction we need to apply right hand grip rule. So hold the conductor in your right hand such that the thumb points in the direction of conductor. The curl finger will give you the direction of the magnetic field. Now the direction of the magnetic field here will be cross, that is perpendicular to the plane and going inward, going into the plane of the paper. So this cross will give you the now direction of the field. So it is cross. Now P is moving in a magnetic field which is perpendicular to the plane of the paper and going into the plane of the paper. So this is magnetic field B. Now let me change the notation. I'll take this as B1 because we have A and B as the conductor. So the field, let us take it as B1. Magnetic field at a distance d due to current I is B1 I took, because B notation we have already used for the conductor. So I'll use the suffix 1, B1. Now because P is moving in a magnetic field, it experiences a force, and the force experienced by a charge moving in the magnetic field is given by QEB sin theta, and theta is the angle between V and B. Therefore force on proton F is equal to QVB. Q you can take it as E because it is the proton. B here it will become B1. QVB, Q is charge is equal to E sin 90 because V and B are perpendicular to each other, or F is equal to E into V into B1. Now substitute for B1. E into V into mu naught by 4 pi mu naught by 4 pi into 2I divided by d. Therefore force F acting on the proton is given by F is equal to mu naught by 4 pi mu naught by 4 pi into 2I EV 2I E into V divided by d. Force is mu naught by 4 pi into 2I E by d. Now they were asking the direction also. If you can recall, in the last session we learned that when two parallel currents are placed close to each other, and when the currents are in the opposite direction, the force experienced by both the conductors are repelling in each other, or they act away from each other. So here, or you can apply Fleming's rule to determine the direction. So if you use that, you will get the force as directed away from the conductor, and it is acting perpendicular to the conductor. So the force direction will be like this. If we are acting away from the conductor and perpendicular to the conductor, and if two currents are in the same direction, they will have attractive force. If two currents are in the opposite direction, then the repelling force. So when we have two conductors carrying current in the same direction, the conductors will experience an attracting force. That means both the conductors will attract each other. And if the currents are in the opposite direction, the conductor will repel each other. So here there will be a repelling force, means the force will be away from conductor A and B. The force is directed perpendicular to straight conductor and away from it. This completes the problem. Hope you understood it.